You want to discuss on any specific topic?
8 people are online. No, I just wanted to ask if you've come across something in the data sheet which is mentioned tube side is designed for differential pressure.
Mm-hmm. So what actually you want to know in that one?
No, because for example, my shell side pressure is X.
Mm-hmm.
And my tube side pressure is Y. And there is another extra statement in the data sheet which says tube side is designed for differential pressure, which is less than the tube side pressure. So what I want to know is in the design for tube side, we have to consider tube side pressure or differential pressure, which is mentioned.
If they mention that you need to consider the differential pressure, then you have to consider. Otherwise, it will be tube side pressure.
Okay.
They mentioned in the specification, no, that to be considered this one.
Yeah. It's actually a replacement job. So the existing GA says that, and datasheet says that tube side is designed for differential pressure. And this differential pressure is less than the tube side pressure. The tube side pressure is, I think, design pressure is 60 bar,
Mm-hmm.
and differential pressure is 40 bar. And shell side pressure, I think, is 80 bar.
Actually, because if you design by 60 bar, then you are on the safer side, more safer side.
Right.
Yeah, but if they are saying to design by differential pressure, then you can go with 40. Then your maybe the thickness and that one will be reduced with that one. We'll get that one.
Basically, only I think tube sheet thickness will be affected.
Can you pardon once again?
I think the tube sheet thickness will basically be affected.
Okay. Okay. Anything? Any more?
Hello?
Okay. Yeah. Anything? Anything more you want to? Any other points?
No. But 8 are online actually.
Yeah, 8 are online, but they're not. I think just Vivek came here, and again he left.
Maybe network issue.
Really, it's a network issue, or they this in that maybe they left. Because many are here joins they just to discuss if somebody have some issues, then they want to discuss that issues, and they give their opinion or their feedback on that one. Like that. So
Yeah, I mean, last seen some.
last time I think
I'm
you
just
invited.
checking how to invite. I forgot.
You're inviting to the person who are online, no?
Yeah, I mean, last seen some. If you have something, you can also discuss. I mean, nothing is coming on my head.
Okay. Just we are thinking some of the documents and that one, whatever we discussed on our group and that one, no? They posted some of the queries and that one. So these whatever the points what we receives on that one, it's their opinion, and whatever way provides it's based on our experience and that, but there is a difference between the opinion about what way says and what actually it is required. So how do you way differentiate about these things? Did you got my
I think people will have their own perspectives, correct? Because, I remember a case where there was a topic regarding using hemi head and ellipsoid head. So I think one of the person was saying that there is no economical advantage using a Hemi head. So I totally disagreed with that, because since I am into also estimation, so price point of view, I am pretty aware. So I was not sure why that person was saying. He was not agreeing on the point. He was from the end user side itself. I think he was working for Babco in Bahrain. So yeah, he was from the end user side, and he was saying there is no economical advantage of using a Hemi head over a Lecture head. So yeah, I don't know how you can give a conclusion unless and until you agree. You can compare the prices and check, because for ellipsoidal head obviously weight is more, thickness will be same like shell, and then the forming cost will be also more. If it comes to a Hemi head, it's almost half of shell thickness, uh, and weight is less, forming cost will be less. So I'm not sure how he can justify his point.
Yeah, maybe he is not worked with Hemisphere or something like that, or maybe just giving his opinion because it's about that one. But Hemisphere normally it's when there is a high pressure, and that one we go for that one. And the
Correct.
costing compared to ellipsoidal and that one, it will be more. And normal this LNG storage and that one, the very big high pressure equipment storage
Yeah,
will be
like
done in using the
bullets and all. Yes.
yeah, using that Hemisphere only they'll do. Yeah, that's why I'm asking how we have to differentiate between the what actually is required and what their opinion given.
Actually, what is required, I think people have to come from the code itself. Then you can say, okay, this is actual. Otherwise, it is just based on usual practices. How one wants to proceed.
Okay, based on the codes, what you're given the information we have to
Yeah, if
show.
somebody is giving something from the code as a reference, then yes, you can say this is actual, okay. But somebody is just saying based on his experience, then that is something totally different, no?
Yeah, yeah. One more
Maybe
point.
things are there are things which is not there in the code. So then even if something you have to follow, even if it is good engineering practice or something, it will be there as a reference to somewhere, even if it's Dennis Moss or some reference books like that.
Yeah, yes.
Not just one day it will not pop up out of one engineer's mind. Okay, we'll scroll like this.
And this Dennis Moss and that one also, they given very detailed and from many years, we are using that one. So I think it will be very beneficial. Means very good guidance they given in the Dennis Moss compared to the codes, because codes are very vast they given. Means we are understanding only after experience only we can understand that one, codes and that one. But Dennis Moss, even the junior also can be start understanding the whatever they mentioned and how they clarified the things and that one. It's a bit easier. Like we can consider as a book, any textbook. Just we are reading like that we can apply the things like that. I think Sriram has joined. Sriram, can you please introduce yourself? Sriram, you are on the mute.
Hello.
Yeah, 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 Sriram. Can you please introduce
Am I
yourself?
audible?
Yeah, yeah, you are audible.
Yeah, I'm vertical architecture and design.
Okay.
Designer.
How many years?
Total 8 years.
8 years. So 8 years with you're with.
No, I have shifted two companies. Yeah.
Okay. Well, total static equipment you have 8 years of experience, right?
Yes, yes, yes.
Okay, okay. It's in India or outside?
Yeah, in India.
Okay. Do you have any queries or any issues or any solution? Do you want to discuss here?
Currently, I don't have any. I just wanted to join the chat and see what's going there and learn about all those things. Yeah.
Okay. Just now we are discussing about heat exchanger tubes designing. Uh,
Yeah.
you had any means you worked with heat exchanger also, no? Hopefully.
Yeah.
I was working in plate type heat exchangers are there, welded plate type heat exchangers. Yeah.
Not shell and tube?
No shell and tube.
Okay, you maximum work with plate type. So plate type normally it comes with this one, no? ANSYS design or something. It's not how you will design this plate type heat exchanger?
Yeah. In code, there have been requirement has been mentioned in mandatory appendix 46 or 45, I think so. 45 for pressure part means such as a prime plate and pressure plate. Yeah.
Yeah, template and
It is similar. Yeah. Yes.
yeah, template and yeah, tell me.
Yeah, I didn't hear you.
Now you are informing something about plate type heat exchanger as per appendix 45, right?
Yes, right.
So you will design as per appendix 45 of ASME section 8 division 1?
Yes, absolutely. Section 8 division 1 itself.
Okay. So you didn't use any ANSYS or anything for analysis?
We use ANSYS in some of the cases where different nozzle projections are there and different type of nozzles for that. Yeah. But usually mandatory appendix 45 is enough. Yeah.
Because some of the jobs we have done, I think, Jerin, you also done any plate type heat exchangers?
No, not yet. Nothing.
Okay, so we done some of the plate type heat exchanger. In that one, normally what we done by using ANSYS and that one completely that the plate we analyze using that software, and the nozzles and that one also will done with that one. So can you please inform how you will do using this appendix 45, because we are not aware that much, because Jerin also is not worked, I am also not aware because
I am traveling. In next session or in some next session, I will share those drawings or any data regarding appendix.
No, data and that one is not just casual. You can tell me how means normally as a layman you can tell me how.
What we do is we have to calculate all the bolting load as per flat non-circular flanges as per appendix 2 and flat surfaces as per let I quick check. Yeah.
Means non-standard flange, using this non-standard flanges you are considering this plate type heat exchanger, right?
Yeah, in appendix 45 their formula has been given for M and Y values of gaskets, means how to be calculated all those periphery and all those things.
Yeah, that's non-standard flanges they given, means you are considering this is as a non-standard flange and you are designing with plate type heat exchanger.
Yes, absolutely.
Okay. Okay, just I think you not work with shell and tube heat exchanger. Now we are discussing about something about shell and tube heat exchanger. We are just discussing about the differential pressure because you not worked, so you not be aware. So just we want to inform. In shell and tube heat exchanger, there is a tubes are there inside, and there are some that tubes is connected with some tube sheets, and there above that one there is shell is there. Like in plate heat exchanger, the complete fluid is passes with the two plates, but here one is passing fluid is in the tubes and another is passing fluid in the shell, like this in shell and tube. So just now we are discussing about that one.
Yes.
Okay. And one more thing we discussed about the hemisphere head. Do you come up across anything about hemisphere's head?
Which, sir?
Did you also done any vessel design? Big vessels?
Yeah. Pressure vessel design was part. Yeah.
Yeah, in that one any hemisphere did you use?
No, I didn't use any hemispherical. I have used ellipsoidal as well as toruspherical. Yeah.
Okay. Normally this hemisphere head comes whenever there is a huge pressure on that time we go for this hemisphere heads, and means completely vessel as a it's similar to, it's a sphere completely. In normally in the cold storage, high pressure storage, in that cases we go for this one. This ellipsoidal and that one torus spherical, these are comes normally the pressure when less on that time it will be, but hemisphere it's a high pressure.
Yes, yes. Up to what thickness do you use like ellipsoidal heads?
There is no
I have used up to
actually there is no any specific range then we have to, but when there is a huge pressure on that time we go for hemisphere, but there is a thickness or material will be saved by using that one, and also it will be withstand with good as you might be seen that one, if you remember the inside the pressure what it will be acting complete on that surface. So if it is in shape of hemisphere, the whatever the forces is coming on that one, it will be equally distributed on whole the surface of that one. But in ellipsoidal, if you see the wherever the bends are there, there will be more pressure and there is failure chances will be more. But in hemisphere, it should be completely you will get the forces will be transferred equally, and it will withstand with more pressure with that one. Like that it is. Right, Jerry?
Yeah, I was asking Sriram like what thickness he has designed.
I have done up to 36 mm thickness. Yeah.
Probably that's why you have not come across its heads.
Yeah. Yes. 36 mm.
Did you done any column?
Another one thing I want to ask. When we go for designing bellows, means what's the criteria for bellows for tube type heat exchanger?
Yeah, but you didn't come across any shell and tube heat exchanger. Bellows it comes in there only.
Yeah, that's why I wanted to learn about that bellows.
Okay, first I think you have to learn about the shell and tube heat exchanger, means simple design. Then bellows are a bit complicated. A bit complicated means actually, Jarin, you want to add something here?
Expansion bellows actually, when we don't design, we outsource the design.
Bellow design in that one.
Yeah.
Okay, bellow design normally, yeah, I will just add here. Bellow design normally what the expansion of the whenever the heat comes to contact with this shell of that shell and tube heat exchanger, on that time what happens, the expansion of this shells takes place. So when your tube sheet is connected to your shell, then if it expands, then your tubes are connected to tube sheet. So there are chances of cracking that one. To avoid that one, we provide this bellows, and this bellows when we provide, when heat increases, because there is a different temperature in tubes and different temperature in the shell. On that time what happens, when tube temperature is less and shell temperature is more, so it starts expansion, shell starts expansion. On that time shell to take care that one will provide bellows, and there are different ways, means different criteria, one bellows or two bellows, how depending on the temperature or factors, how which material is selected. Considering these we take, and these all inputs if you provide in PVElite, it will directly design and it will give answer to you.
Is there any specific error terms on PVElite for that selection of bellows and temperature difference for that? When we are going for design shell and tube type heat exchanger, is there any specific error pops up or anything else?
Any specific error it not pops up, but if your client says that provide the bellows, because normally bellows are avoided, because bellow there are, when you weld that shell and that one, there are chances of leakage and that one, maximum chance, because this is a different form, and that shell will be formed with connected with a different form. So and heat also will be more on that place, so there are chances of leakage. So normally clients avoids to provide bellows, but the temperature is very huge difference, because your shell temperature is the fluid which is passing in the shell and that fluid which passing in the tube, there are huge difference between the temperature, then normally we go for bellows, because the temperature, due to this temperature difference, there are much more chances that it can expand that shell. So in that case, well, it's not give any error in that one, but if you provide the bellows, it will calculate depending on, because in PVElite, whatever the inputs you provide, accordingly it will calculate. If you not provide bellows, then it will not consider your thickness or your it gives that maybe higher side or like that it will do, but it will not say, it will not give any error that one. Okay, anything?
Sometimes bellows are used even just to reduce, I think, tube sheet thickness also.
Bellows are setting shell to, because this connected to shell, and tube sheet is depends on the you are connected to tubes, and whatever the internal pressure for that one, depending on that one, it is considered.
So when we will provide thick bellow and when we will provide thin bellow?
That's depending on the client requirement.
Is there any specific requirement like thermal expansion below 5 or below 10 mm?
Yeah, these all factors we have to look into the client specification. Accordingly, we have to select this, whether we have to go for low bellow or high bellow, like that, high thickness bellow or something.
I am not asking about high thickness or lower thickness. I am asking thick bellow or thin bellow.
Yeah, that's I am telling. Depending on your shell thickness and that one, no. If your internal pressure and that one is more and that one, in that cases you have to go for the thicker bellow. And if your shell pressure is less than that one, the shell thickness also less, then you can go thinner bellow. And these are all given in their specifications.
Okay. Okay, sir. Thank you.
Okay. Can you please introduce yourself?
Yeah, sir. I am Ankush Kumar.
Okay.
Okay.
How many years experience you have?
I have 5 years of experience.
5 years. Okay.
Yeah.
Did you come across any of this plate type heat exchanger in that one?
No, I didn't work on later. I work on silent tube heat exchangers only.
So you work only shell and tube heat exchangers?
Yes.
Okay. Did you work any shell and tube heat exchanger stacking one on above?
Yes, I have worked on that.
Okay. In that case, if this stacking heat exchanger, if it is stacked on the nozzle of this one, how you calculate that nozzle forces?
Nozzle forces?
Yeah.
The nozzle forces is not depend upon that. We will apply the load on the saddles. On the bottom exchanger, we apply the total weight on saddles of the bottom exchangers. Top exchanger.
Yeah, that is okay. The whatever loads you're transferring to the bottom,
saddles.
Saddles. But if there is a heat exchanger below, there is a vessel or heat exchanger. On that one horizontal heat exchanger, on that one, if you one nozzle is there, big nozzle, on that one you are mounting a vertical heat exchanger. How will that vertical heat exchanger, if loading on the one nozzle or flange, how that flange you consider it's suitable or not suitable? Did you come across anything?
I did not work at this type of exchanger till now. I will ask with my seniors.
Okay.
And update in the group.
Okay. Sriram or Jarin, did you come across anything, something like that? Because this was discussed in the last discussion.
No, I didn't come across it.
Because they want.
Exchangers, generally, during my pre-design, we don't go in detail of like this situation.
Yeah.
Because generally, the detail engineering, they only take care. Engineering, so we don't go in depth during estimation stage.
Okay. Sriram, did you come across any vessel which is mounting?
No.
Any vessel mounting on the?
Yeah.
Any vessel, because there are some vessels also, small vessel. Means below there is a big vessel. On that one small vessel is mounting on that one.
Yeah, like derators.
Yeah, derator and that one, like that. So did you come across anything?
No, there wasn't such thing in my experience. Yeah.
Okay. So actually the question
Actually,
is,
what we
yeah.
yeah, yes, sir.
Yeah, actually question is that that non-standard flange means nozzle is there, and in that one there are mounting that equipment, and that forces or loads they want to transfer to that nozzle and to verify whether it will be suitable or not, like that. So normally in there is means what we used to do, we normally that whatever the forces or loads comes, we just we calculate the total loads and total movements of that one, and we'll apply on that nozzle. We'll do.
Okay. Just like WRC 107 and other things. Yeah.
Yeah,
Am I right?
yeah, WRC and 107. If it is standard nozzle, then we'll apply WRC 107. If it is not standard, then we'll make it a separate one nozzle. And on that one, as a non-standard nozzle, on that one we'll add a forces and moments.
One another question I want to ask.
Yeah.
When there is wind load and seismic load, some other codes have been asked by a client. Means some platform has been located in the sea, and there is some wind load is there. And how do we calculate those? Means how do we enter these loads, calculated loads on a vessel in PVElite? I don't know about it. Can you just little bit elaborate?
Jerin or Ankush, do you want to answer?
What load? Snow load?
Seismic and wind
Snow
load.
load is there. There is wind load, and wind load is not specific as per any code listed in the PVElite. Yeah. Which is a code? Some Malaysian code is there. I don't exactly know that code. Yeah. Currently, I don't have it right now. But client has been provided that wind load generated by means their design was there. So we have communicated to client that these types of loads are not available with us. Means codes not available with us. Then he have performed and he have given wind loads and seismic loads. Yeah. Then these value, how should I put into PVElite for loading this?
PVElite has an option for user defined, I think, right?
Yeah, I haven't come across, so I don't know. Can you please little bit elaborate?
Sir, I think there is an option, right, for PVElite?
Yeah, Jerin. Yeah, there is a option is there. User defined loads are there, but only there few points you can add. Like you can add the wind factor. You can add the there is 2-3 only parameters are there. Only those parameter you have to ask to your client. Only give me these parameters, and you have to add that one. So there is a user defined also is available. But that parameter.
Some moments and
Yeah, some moments in that one. It's available. 3-4 parameters only available. Only that you have to ask, and you have to put that one. And also there is one more option is there. Some spectrum option is there. You have to ask to him that if you don't have this code in that one, give me the spectrum. Spectrum means it's a different levels. There is a different forces applying on that equipment. So that spectrum, if we use, you can apply that loads. Means different levels. You have to 1 meter it will be this much load. 1.5 meter this will be load, like that is there. So you can apply with that one also.
One thing I want to ask about when there is a huge column is there, tower is there, then how do we calculate wind load for different heights? Means is there any specific criteria we have to apply? How it will be for designing purpose? Means how it will be calculated?
Yeah, that's only I'm telling. It's a spectrum method you can apply. The spectrum method when it's given in their specifications. So whenever there are two ways, just we have to apply the factors and that one, the load, total loads. But in spectrum method, there is a different timing and a different height. On that one, it will be applied. So there are maybe 10-15 different heights they are given. On that and different heights, you have to apply that load. Like that, it is option is there. Spectrum method.
Okay, and if there is any buckling load, how do we calculate it? Buckling load means is there any top platform is there on the vessel?
Jarin, Ankush, do you want to answer?
So I don't have worked on vessels, so I have.
Okay. Normally buckling load and that one, whenever you have the platforms and that one, it will calculate it depending on that local area. So local area, you have to using the WRC and that one. That local area forces and that one you have to calculate whether it will be suitable, that shell part, like your lifting leg, how you will calculate. No? Similar to you have to calculate this platform and that one.
Not right now.
Okay, Ankush, did you come across anything, any column, process column design, that one? Ankush or Sriram?
No, sir. No, sir. I didn't come across about it.
So
I
you
work on the exchangers and only exchangers.
only exchangers, okay.
Yeah.
Okay. In exchangers,
Shouldn't
yeah, Jan.
yeah, shouldn't you?
Yes. Selective heat exchangers.
Okay. Not fin fan. Who does it?
So come again, please. Your voice is breaking. I
So-
may be
so-
work in future. Yeah.
So you have an idea like how is the design done?
For D type,
Yeah.
sir, I don't have idea about D type. Maybe upcoming next project I will work on it.
Okay. So you have any idea about D type? Because in compress we don't have the option to design D type.
This is there are only two types, major two types: high two type exchanger or high pressure, low pressure type.
No, that is something. Jarin, you are asking in PVElite the option, no? The PVElite have these options. You can select the whichever type.
Yes. PVElite have.
Yeah.
PVElite have that option.
Yeah. So in compress, I think it's not there.
No.
Okay. But in PVElites, they given the different whatever the option is there. So it's almost all are available. It means whatever TIMA different types are there. No? These almost all are available.
Yes.
Sriram, you are asking about something. This column on. Did you work on columns?
Not exactly, but
Process column. Did you work
there
on
was one vessel. Yeah.
any process columns?
There was one vessel. Yeah, there was only one vessel. Yeah.
Uh-huh. So you designed that one?
Yeah, there was some tray and means some distillation tower was there. Yeah,
Okay.
some anchor support we have provided, and it was supported by some framework was there. So there wasn't any wind load and seismic load was been compensated at. We have been calculated all those on PAS named any software. Yeah.
Mm-hmm. So you didn't done on PVElite, you done on PAS using PAS software, right?
Yes.
Using what?
There is a software called PAS, right? Yeah.
PAS named the software is there.
Did you use
PAS?
Yeah, PASS, PAS, right?
Yes.
Okay.
Yes, right.
Did you work PVElite also?
Yes. For normal pressure vessel, we are using PVElite itself. Yeah.
Okay. What is the major difference in PVElite and PAS? Because I am not work with PAS, I work with PVElite. I see.
PAS is little complicated and it is underdeveloped or some what we say it is basically depend upon some Russian standards and all those things.
Okay.
Yeah, some forms are there in Russian. Like that way, for Russian it is easy. I think it's Russian. Yeah.
Okay. Then Russian, it's because
So
in
you are working on projects for Russia.
Yeah.
Okay.
So Russia, because in
So
PVElite,
Russia is also using ASME Section 8 division. No, I was asking. Russia is also using Section 8 division one.
Yeah, they actually accept those codes, but all the calculation should have to be dual languages itself. Yeah.
Dual language, you mean English and Russian?
Yes.
So how do you manage the second language?
Some language translator we hire. Yeah.
Okay.
And this software also gives this the calculation in Russian language.
Yes.
Okay, this.
And
Oh,
as well. Yeah.
Okay, then better.
so maybe not just the software, every procedure, everything needs to be dual language.
Yes, full dossier has been converted to Russian as well. Yeah, full dossier means quality part of it and production part of it. Everything is converted in dual language. Yeah.
Okay. So this translator is from India?
Yeah, actually, they have been outsourced from purchase team, so I don't know exactly. But yeah, they are in India.
Okay.
And this software is from where? It is from Russia. Past software.
No, it's not from Russia. It's exactly I have to check.
Okay. And also I seen that this past software also we can design some piping and that one also, no?
Yes.
Because in PVElite we cannot do, only the static equipment only can, I mean vessel and heat exchanger only can do, but not
Yes.
in this pass also we can design piping, we can design tank also.
Yes.
This cone roof tank, floating roof tank, API 650 tanks, all can be done.
Yes.
Oh, then it's good then. You have to try then. Did you done any tank design using this pass software?
Yes. Some pressure vessel I have designed.
No, tanks, API 650 tanks.
No, API 650 tanks.
Tanks means?
API 650 storage tanks, atmospheric pressure.
No. Storage tank I haven't designed using pass. There is provision, but I haven't used it.
Okay. But you seen that API 650 tanks code is available in this one, right?
Right.
So in this pass software, as you told, piping also can, means it's similar to Caesar software's output it comes. Did you work with Caesar software? Caesar, it's specifically for piping one, no?
Piping, I just work on pressure vessel and plate type heat exchanger and shell and tube. I have designed, but just simple one. Yeah. Not that one.
Okay.
Kelvion is basically more into heat exchangers, right?
Right.
That also plate type heat exchanger, I think, is told.
There have been numerous products are there. In which sector I am working, it's on plate type heat exchanger, welded plate type heat exchanger.
Okay.
What is the common metallurgy?
Yes.
What is the common metallurgy?
Means material of that heat exchanger.
The material.
Yeah. SF grade 70 is mostly, and some other materials also used. Some SMO, alloy, titanium as well. Yeah, nickel as well. Yeah.
So when main theme is carbon steel, the complete other components will be also carbon steel. It's like that.
Yes. Means there should be some. If there is some specific liquid is there, which is means hazardous liquid is there, or corrosive liquid is there. As per that, we have to select materials. Yeah.
Okay. So material selection is your scope?
No, actually, it's a process engineer's role.
Okay, so it will come in the data sheet.
Yes, absolutely.
There is no tube, right? There is a tube concept, right? In plating tubes.
No. There is no tubes. Only plates. Yeah. plates has been stacked together and forms one complex part, and it will be used as same we can design as a shell and tube type heat exchanger, or we can say as pressure vessel. Yeah.
I think there is between the plates there are like gasket seatings, right?
No, for welded there is a welding is there.
So there is no gasket seating.
No, there is no gasket seating.
I think gasket setting, if required, that also will be at the edge, right, Sriram? Because it's not inside. Inside, the liquid is flowing.
No, there is two different type of heat exchanger in plate type. Some of them are welded, and another some are gasketed.
Yeah, bolted.
And gasketed everywhere is on edge. Gasket is there, as you have said.
Yeah, bolted with that. Okay.
Both type of heat exchanger I have working on. Yeah.
So in your case, there is no gasket, directly welding.
Yeah, directly welding is also there. We can directly weld as well. Yeah. In my case, directly welding is
plates are welded to what?
Plates are welded to plates.
Oh.
There has been thin welding was there. Yeah.
Okay. Anything? Any more? Any other topics? Any other points? Sriram, Jarin, Ankush.
No, there are
No, sir, no.
Sir, one of things I want to ask, do you have been work on PED European Directive 82000 code?
PED, yes, we used that standard with some of our projects and that one. What actually you want to know in that one?
In that one, I needed help for purchase order specification, POS preparation. Is there any work you have done, or do you have any POS available with you, or you can guide us on different material? Because in 82000 is more stringent than ASME and EM 13445, and there have been code has been conflict is there. So I was required to guide scope on it.
Means in PED, from PED specification, you want the scope of purchasing, right?
Yes. POS.
Yeah, just
specification which we do as per ASME technical delivery specification, which we say.
Yeah, means you want a pressure vessel spec for from PED?
Not exactly. 82000 design code is 82000. And their material selection for material requirements are different. Means for when we go for material, for an example, there has been some criteria has been set for stress category and all those things. For stress category 1, this material P355NL2, this some material is there, which is equivalent to SF516 grade 70, but it cannot be used below 60 degree, and we cannot use more than 60 mm thickness we can use. Those types of, yeah.
Basically, you want technical delivery condition for that.
Yes, technical delivery condition as per ASME, yeah. Do you have it in 82000?
I don't have anyone. I will check with my colleagues. If we have, then I will provide.
Yeah, okay. Thank you, sir.
Okay, bye. Thank you.
Thank you all. Thank you.
Thank you.
Bye.
Bye.